Morning. Why doesn't this work? Oh, it does. That's me. And those of you who have been to Trooper for the last 5 years know that I always speak about some crazy stuff. And this year, as Eno was asking me to talk about something, IPv6 something, I went like, what can I talk about? It's old news. And after all, we've been talking about that for the last, how many years? 5, at least. So, what can I do? And then it hit me. Everyone is focusing on these things here. We're educating people, we are doing research, we are exposing the vulnerabilities, we know all about RA Guard, and oh, Fernando's not in the room, too bad. He could tell you how to construct the extension header so that you can get around any hardware-based filter, and so on and so on. And some people go and then they design the networks, and they even test things in lab, and then you have to deploy it. And so far, I haven't seen many people focused on the gory parts of deploying it. Yeah, talking about how to do it, sure. How do you set up the addressing? Sure. How do you actually do that stuff? Not that much. Okay, before I go further, how many of you have IPv6 in production? So what am I talking about? Okay, for the 3 others, when you start thinking about deploying IPv6 network-wide, and you start counting how many things you have to touch and change, servers, switches, routers, firewalls, load balancers, you have to rewrite every firewall rule, right? It's like, oh no. And the worst part is that it's utterly boring. There's nothing new here. You're just deploying another protocol that looks exactly like the other protocol, only the addresses look different. And the configuration syntax is a little bit different because the vendor couldn't get his mind together and just mirror the syntax. They had to tweak it a little bit, just for the fun of it. So it's utterly boring, and whenever you're doing a boring stuff, you know what happens. You get it wrong. Every single time, consistently. Just to give you a real-life example, and I'm sure that everyone who has IPv6 in production has seen this. You enable IPv6 in the database segment, and it works. You enable IPv6 in all the other segments, and it works. You test the connectivity, you do pings, and it works. And then, weeks later, the other team adds the quad A record to the DNS server, and bam, your application is down. Because no one ever configured the firewall rule here. And no one ever tested whether the app server can actually reach the database server over IPv6. And the moment you add the quad A record, app server goes from IPv4 to IPv6, bam. However, there's one thing. Every single well-defined task that is repeatable can be automated. Which means, if you can teach a monkey how to do that, and it really is a monkey job, then you can teach a script how to do that. It's just the question of writing that script. I always tell people that, if you want to automate something, first you have to know what you're doing. You have to abstract things first. Before doing that, you have to standardize what you're doing, and it doesn't make sense to standardize your existing mess, so you better simplify things first. So yeah, this is the goal, and this is what every vendor is selling you, and they skip the chain. Because no one wants to mention that you have to do 3 steps before you can spend money on their product. In this particular case, it's even worse. Because first, you have to figure out what you actually have. In many cases, people don't even know what they have in the networks, particularly when there's the boundary between the host team and the networking team and the firewalling team. Oh, and why do we have that firewall rule in there? Oh, someone inserted it 3 years ago. We don't know what it's doing, so we better not remove it. So you have to audit all the stuff. You have to clean up the mess. Then you can start thinking about simplifying it, going to the previous slide, and you have 3 more steps to go. But you know what? IPv6 is such a convenient external enemy. So maybe you can use it to push this through. Particularly if someone at the board level starts talking about IPv6. Oh, we would love to do that, but you know what? We need to clean up our stuff first. So maybe you can use that excuse. I used that excuse 20 years ago when ISO 9001 was popular. Instead of documenting existing mess, I just re-architected the business processes in the company. And when someone started complaining, I said, well, no, you know ISO 9001. We have to do it this way. And it worked. Anyway, before you can start doing any stuff, you have to prepare yourself. And since we don't have nicely abstracted network state with configuration templates, yada, 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 like we should have, well, you should have been on my yesterday's workshop. This is what we have to do. We have to collect the existing configurations. We have to do some cleanup, and then we have to classify the functionality that we have in the network today. Some functionality is not IP dependent. Some functionality will remain on IPv4 because we just don't care. For some things, we'll need dual stack, and some things will just move over to IPv6 and we'll turn off IPv4. So there's things that are not IP dependent, like host names, usernames, passwords, yada, 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 yada. No need to change password if you go to IPv6. Network management might remain on IPv4 just because vendors are so bad in doing it properly over IPv6. MPLS control plane, if you have it, will remain on IPv4 because no one has ever bothered to implement LDP over IPv6, even though the RFC is probably out by now, or not because no one cares. We will need dual stack functionality on interfaces, routing protocols, route maps, firewall rules, load balancing rules, you name it. And maybe, if you're really lucky, or if you're like, what's his name, Ron Broersma. He is the guy that had ARPANET Node 3. He said, I want to have my network management over IPv6, and dear vendor, if it doesn't work, don't even bother calling me. So now you know why Brocade had network management over IPv6 way before they supported IPv6 routing on their data center switches. It was amazing. It took them like 2 years to get from management over IPv6 to routing IPv6. But now you know why they implemented the first part. So for example, you might have a script that would go through the configuration and you would go like, yeah, doesn't matter. I can ignore that. This is okay. Oops, we need to migrate this. Okay, we can leave this alone. We can leave this alone. And then as you go through the configuration, you will eventually find something that you haven't seen before, because this will be an evolving effort. So for example, you might hit something like this, and then you will like, I don't know what this is. This is a showstopper. Stop. A human has to look at this and figure out what to do. So you can only automate so much. Automating everything doesn't make sense. You can spend your life trying to solve this problem. And then, somehow, you have to take the IPv4 addresses, and you have to find out what their IPv6 counterparts would be. And this is like the toughest part of this job. Well, not if you have IPAM. If you have this single source of truth in your network and you actually use it, and it's consistent and up to date, then your job is done. Okay? Because you just, whenever you have an IPv4 address in your IPAM, you just add a corresponding IPv6 address and you have the mapping. It's in the database. Oh, supposing obviously that your IPAM tool does support IPv6. Some still don't. If you don't have this well-defined mapping, where will you get it? And well, if you have your subnets in Excel spreadsheets, that might be a problem. So yeah, you can export an Excel spreadsheet and then write a Perl script that will generate the mappings. But what if you're even worse than that? What if you have no information? You might have subnets in an Excel spreadsheet, but you have no idea what IP addresses you have out there. And honestly, I've seen people in that state. So if you have no IPAM, then the device configurations are the only source of truth. Because after all, the network is running. I mean, it sounds awful, and it is, but that's reality. I know someone who actually wrote a script that did exactly that. So he wrote this script. And because he's a networking engineer, he's so ashamed of his code that he doesn't want to release it on GitHub. And I was trying to push him to do that because there's no problem. It's like a homegrown tool, but he doesn't care. He would love to open source it, but he goes like, I'm ashamed of my code. I can't do that. So you won't see the script. Anyway, what he did was he wrote code that parses Cisco iOS configuration and I think F5 configuration and stores all the information it gathers in a database table. And he invented some crazy data structure so that he can do longest prefix matching in Perl at reasonable speed. And then he would use that tool like find this IP address. As you know, someone is calling the support center saying, I have a problem, and you can figure out his IP address, but you don't know where he is or how he's connected. So he would have this tool that would say, find this IP address, and the tool would go and tell you, well, this IP address could be in this subnet, which I've seen on this particular router that's sitting in that particular office. And I think he even supports VRF, so if you have multiple routing domains, he would go like, OK, it could be on this load balancer here, or it could be on that firewall there, or it could be on that router there. But at least you know where to start to look. So you have to write something like that. And it's relatively easy, but it needs to be done. And as I said, Perl is your friend, or Python if you like it. But Perl was forever used for things where you needed text scraping or screen scraping or whatever. So create a script that parses the configuration file, find the IPv4 addresses, establish some algorithmic mappings between IPv4 and IPv6 addresses. So you might say, if the subnet mask is /32, this is obviously a loopback. And I'm mapping my IPv4 loopbacks from network 10 into IPv6 subnets in this range. If the network mask is /24, this is obviously a LAN subnet. And I'm mapping my LAN subnets using these other algorithmic mappings from IPv4 into IPv6. Okay? So you just write the translation rules. For loopbacks, we go from this to this. And you figure out which bits from IPv4 address map into IPv6 subnet. For /24s, we do this. For /30s, the point-to-point links, we do this. And so on and so on and so on. And then the script should go and parse the configuration text file, so like the router configuration. And for every IPv4 specific command, take the IPv4 address, map it into IPv6 address, generate the corresponding IPv6 command. Okay? There will be problems. I mean, this sounds too easy, right? I could hack this together in a day for interface addresses and routing protocols. That would be like a piece of cake. Access lists will be interesting, particularly for vendors that have different IPv4 and IPv6 access lists. If you're using something like Cisco's ASA, you're probably pretty well off because it has objects, and in the objects you can combine IPv4 and IPv6 addresses. So that would be like, yes. Of course. Which brings me back to the cleanup part, right? Or you can just create an object for every subnet you see in the firewall rule, which is like totally crazy. Route maps will be interesting, and class maps and policy maps in Cisco IS terms will be particularly interesting. These things also have this great property that they are impossible to edit. If you have a policy map or a class map and you have to remove like the third statement out of 5, or insert a first statement, good luck. It's totally impossible. Cisco, by the way, has this nice configuration diff tool, which tells you what you have to execute to get from this configuration to this other configuration. And it totally fails when faced with a policy map. It just cannot be done properly. But let's ignore that. If you are lucky and you actually have a device where the vendor was brilliant enough to implement XML or JSON, which would be like Juniper or Arista, sort of. So if you can get the configuration from the device in XML or JSON format, then you don't have to do any screen scraping. Because this is now easily parsable. You just get a data structure and you walk through the data structure and you generate a similar data structure with IPv6. Oh, by the way, before someone tells me that Cisco iOS can also produce configuration in XML format, which it can, that thing has no hierarchy. So it's totally useless. Some things, I think I actually took this off iOS. So some things that are like 20 years old, like interfaces, they generate proper hierarchy. The newer things, they just convert every line into an XML thingy. So you don't even get correlation between adjacent lines in the configuration, which is like, excuse me. So yeah, I hope you're using Juniper if you want to do this. They do a proper job of generating XML that actually makes sense. So if you're lucky enough to have XML, then you don't even have to write that script to scrape everything and do whatever. Either you just create an object and then pull out the values, or if you want to get even smarter, there's this thing called XSLT, which is a language that you can use to convert an XML document into a different XML document. Okay? So you can just take the XML configuration from Junos, run a translation on it, and generate a different XML configuration for Junos. Then you just push it to the device. Done. Fortunately, there's only one vendor that can do that. So from the programming perspective, this is like awesome. However, there is a gotcha. If you totally trust your automation tool, this is the best thing on earth you can do. If you want to inspect the results by hand before committing them to the device, which is probably a good idea in the early stages, then good luck looking at this and trying to figure out what it will do to the device configuration. Although some people claim that XML is humanly readable, I disagree with them. And now for some real-life aspects. This sounds like, yeah, we can get the job done. And then every time I discuss anything with networking engineers, they always go like, yeah, but there is this one corner case where we do this, and I cannot do this thing with this tool, so I don't think this tool can ever work. It's amazing how many times I hear arguments along those lines, which I can only say, stop wasting your time. Solve the 80% of the problem, and the rest can be done manually. Just make sure that the automation script tells you what's left. Because if it doesn't, then you just created a huge mess. So do what you can with the script, then make sure that you know what it didn't do. Okay? But stop wasting your time on solving the last 2% of the problem. Don't ever expect a vendor to come with a product that will help you do that. We had this problem for 20 years. How many products along these lines have you seen? 0. So don't expect a vendor to do this. It will be some assembly required job. You have to do it on your own. If you decide to do it, and please, please, please share the results. It's amazing how many good things can happen if you share your code on GitHub, and in particular, if you tell a few people that the code is there so that they can start spreading the news. All the great network automation tools that we hear so much about these days, like Chef, Puppet, Ansible, Salt, CF Engine, all started with someone solving his problem. Then instead of burying the code and moving on, actually publishing the code on GitHub, so that someone else could modify the code and solve his problem, and now the code is solving a bigger set of problems. If you'll just do this and solve your problem and walk away, good for you, but didn't do anything for the greater good. So please share. Don't try to be perfect. So figure out where the major pain is. It's probably the interface addresses, routing protocols, firewall rules, and packet filters. That's probably your major pain right now when you have to get it up and running. Maybe you don't have to deal with QoS on day 1. Maybe you leave that for day 2. And then when you have this thing up and running and you identify what's missing, then you go and do more and more and more and more stuff. And don't forget minor details, like on Cisco iOS, if you have access group on a VTY line, you also need IPv6 access group, or the router will be freely accessible over IPv6. So there are minor details where you actually have to think very hard about what to do. And then you just repeat the whole thing. Automate as much as you think you need, and come back after a while, automate a few more things, repeat doing. And don't trust the automation tool. A human wrote it. Okay? It's probably not perfect. So I will not waste your time on change management, because I know you all have to do that. But simple things like we can do is collect the configurations you have today, run them through this tool, and then use any sort of source code control system like Git or SVN or whatever to compare the current configuration with the proposed configuration. Most of these tools have some workflow mechanisms. For example, for Git, you can use Gerrit, so that you can force a few people to look at the changes, confirm the changes, and then after you get enough confirmations from different people that, yes, we think this should work, then you go and deploy it. Also, I would strongly recommend, if you do something like this, that you go for full configurations. So take your router configuration. As you go through it, copy it and add the new lines. And continue copying and add the new lines. Because it will be easier for the reviewer. He will see the context. He will be able to say, okay, I see. Here we have an IPv4 address on the interface, and you are proposing we add an IPv6 address on the interface. Yes, this makes sense. Or he would be able to compare IPv4 and IPv6 access lists and verify that they are identical. Things like that. And then test, 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 test. You should know how your network behaves today. That you should be able to write unit tests. And actually, one of my friends wrote a software that automates that. So his software would accept specs like, to get from router A to router B, we need to cross router C, D, and E. And then his tool would log into the routers, do show IP interface brief to collect the IP addresses and the host names, and then log into the source router, do a trace route, analyze the printouts to verify that they actually traverse the other routers. So that would be the pure connectivity test. I know that at least Chris Young from HP and probably a few other people are working on tools that will automate the end-to-end connectivity tests. So in your unit test, you would say, web server needs to talk to app server on port whatever. And app server needs to talk to database server on Oracle port. And then that tool would log into all the servers and verify that this server can actually connect to that server. So whenever you change the firewall rules, you can run this unit test. And it automatically verifies that you haven't blown up the firewall. Okay? Obviously, someone has to write those tests. So it will be a huge effort, but after you've done that, at least you'll know that your network works as expected every time after every change. So you'll have to invest a lot. Well, in this particular case, what I would do is, the moment you enable IPv6 on both segments, I would log into the server and verify that it can reach this other server over v4 and over v6 on the same port. Well, that's a difference. Well, that's a different story. Okay. Understood. Okay, so from that perspective, and I totally agree with you, from that perspective, you have to test whether applications work over IPv6 separately. That's a totally different topic. And for applications that you know don't work over IPv6, just don't add the quad A records to DNS. And yes, there will be some applications that will never work over IPv6 because it's just not worth fixing that code. Great. Okay, and now for some reality checks. You think it will be like this, and it will actually be like this. Not mine, XKCD is an excellent source of wisdom. S is Dilbert. So, I hope we are halfway closer to deploying IPv6. Okay. And that's it. When you get this up and running, please let me know. And if you have any questions, how much time do we have left? Awesome. So if you have any questions, ask them now, or you can always send me